Now, in this video, what we're going to look at is calculating a two-sample confidence interval for proportions. Now, I'm going to use the same data here that I used in the two-sample hypothesis test for proportions. We have a group of smokers and non-smokers. They're asked about a particular policy relating to whether they should, the smokers should be taxed more to cover their health insurance costs. And we in the hypothesis test, we were asking about whether or not those two groups have the same opinion about that, whether the smokers should be taxed. And not too surprisingly, we concluded that, in fact, they did not agree, they did not have the same proportion of positive responses. So what we're going to do here is we're going to go ahead and we are going to calculate the confidence interval for that difference of proportions. Now, the first thing that we're going to have to calculate is the simple stuff, the proportions of each of the two groups. So that's going to be our yes group divided by the total number for the non-smokers case. And then we're also going to need to do the same thing for the smokers case. And then the difference is the center of our distribution. And I'm just going to go with the P1 minus P2 order. Okay, so that's our center. So again, think about our sampling distribution. This 36.99% is essentially the mean of our sampling distribution. And then the way that we calculate the confidence interval is we calculate the standard error for that sampling distribution. And then we multiply that by a z-score that represents our confidence level. And then the mean minus that margin of error and the mean plus that margin of error gets us our confidence interval. Now, here is the formula for our standard error for the two-sample proportion test. This is a little bit different, but it is equivalent to the version that we used in the hypothesis testing formula. Here, we're just separating out the P1 and P2s into separate things. We don't have an overall proportion that we're using, but it is essentially equivalent. You'll see different versions of this formula that use in slightly different contexts, emphasizing slightly different things. I like this version for the confidence interval because it kind of reminds me of the fact that essentially what we're doing is we're taking the standard error for the one problem for the non-smokers and the standard error for the other the smokers in this case, and then we're just essentially adding them under the square root. So they're basically, if you can remember the standard error formula for just one proportion, just keep in mind that essentially you're adding the squares and then you're re-square rooting them. And so you're just taking those two key things that are under the square root in the separate formulas, and then you're putting them together under the one square root. All right, so let's go ahead and then calculate our standard error, square root. So this is going to be proportion 1 times 1 minus proportion 1 divided by the sample size from proportion 1, and then plus proportion 2 times 1 minus proportion 2 divided by the sample size for group 2. And then I double checked my my parentheses, and then I go ahead and hit enter. And again, keep in mind where you expect your standard errors to come out. They're going to come out in small percentages. Smaller sample sizes will tend to be slightly larger percentages. Slightly bigger sample sizes will be slightly smaller percentages. But you know, if you're getting something that's like 17, then that's definitely wrong. And again, you can't calculate these using counts. You have to calculate them using proportions. Then we're going to have our Z critical value, or the scaling factor that we need for our confidence level. If we're doing a 95% confidence level, then remember that There's a bunch of different ways that we can calculate this. I am going to calculate this using the negative norm inverse of the left tail of my probability distribution. So 5% is left out of a 95% confidence interval, 2.5% in each tail. If I use the 2.5%, I'm going to get a negative number. I don't want a negative number for my confidence interval. So I put another negative in front of the norm inverse in order to get a positive value. You could also just take the 0.25, and then just put an absolute value around it. That will also work. And again, for the 95% confidence interval for the z-score, you should expect to get 1.96, which is what we got here. If you've memorized it, you can also just use 1.96. And then let's do our margin of error, is going to be the z-critical score times the standard error. And then our lower bound and our upper bound are going to be the center of the mean of our sampling distribution, which is the difference minus the margin of error. And the upper bound is the difference plus the margin of error. And so we get our confidence interval is roughly 30% to 44%, depending on how you round it. So there is a very significant difference between smokers and non-smokers in terms of their opinion on this particular question. Should smokers be taxed more? Not too surprising.